There are different ways that this happens. An experiment shows one way that heat is transferred from one place to another. Here, a student puts some wax on the heads of 3 tacks. He then sticks the tacks so that they are spaced evenly apart along a steel rod. A Bunsen burner then heats the end of the rod. In a few minutes, the heat from the burner is transferred from one end of the rod to the other. The wax melts and the tacks fall off, one after the other. But how does this happen? The steel rod is a solid. The molecules that make up the end of the rod vibrate more quickly when heated, but the molecules can't move from one end of the rod to the other.
Pool provides a hint about what happens with the molecules of the rod. When someone makes a shot, energy is transferred from the player's arm to the white cue ball. When the cue ball hits a second ball, it transfers its energy to the other ball. Often, the cue ball hits one ball that in turn transfers energy to still another ball. Something similar happens with the molecules that make up the steel rod. As the molecules at one end are heated, they speed up and vibrate more. These molecules transfer energy to the molecules next to them, which become excited and move more rapidly. These molecules, in turn, excite the molecules next to them, and so on. In this way, heat energy is passed on from molecule to molecule, the whole length of the rod. This type of transfer of heat is called conduction. Conduction occurs when heat energy flows from one molecule to another as they collide.
Different substances do not conduct heat equally well. These spokes are made of different kinds of metal, including copper, aluminum, steel, and iron. Here, a student has attached a tack to the end of each spoke. He then heats the hub so that each spoke gets an equal amount of heat. The experiment shows that the wax melts and the tack falls off the copper spoke before any of the others. The next tack to fall is from the aluminum spoke, because aluminum is a better conductor than any of the other metals except for copper.
In general,